Okay, we're going to take a look at case 4, which is repeat quadratic factors. So I'm going to make sure this I pencil can connect. So let's take a look. The first term is linear, but you can notice that the second term is quadratic because it has the power 2 and it's repeated 2 times. So this is what we call repeat quadratic factors. You have a quadratic factor that's repeated, and in general you got ax squared plus bx plus c to the nth power, and this is what you do when you have a repeat quadratic factor. So for partial fraction decomposition, here's what we do. All right, we're going to use, I think it's subscript, yeah, a1x plus b1, a2x plus b2, all the way up to a n x plus b n. This is what we do when we have repeat quadratic factors. We start with the first power, we go all the way up to the nth power. So what that looks like here will be 4 minus x x squared plus 2 to the second power. So for the linear term, that's just a over x. For the quadratic term, again, we start with the quadratic factor to the first power. That's where you start. But you end with the quadratic factor to the second power. And don't forget, this is bx plus c. And then dx plus e. We're not going to use subscripts. So we're dealing with that linear term. First power, and then you go up to the what? Second power. All right, we don't have enough space to write it all horizontally, but this will do. Okay. Now, remember what we did before. We're going to have to multiply this first term by x squared plus 2 to the second power, and then the numerator has to be x squared plus 2 to the second power. For the second fraction. This is x times x squared plus 2, x times x squared plus 2. For the last one, it'll just be x. So you will see that this is the LCM here for your denominators. And what that implies, again, is that the numerators will be equal because you have the same fractions there, just like we've seen in the past. Your numerator will be equal. So that equation again, like we've seen earlier, was 4 minus x will equal a x squared plus 2 squared plus bx plus c x squared plus 2. I'll put the x first, dx plus e. Okay. Now, again, like I mentioned earlier today in class, if you're going to look for the details here, let's go back to my website. Math 262, the new library, we're looking up integration by partial fraction decomposition. You have that video here. So I go over the details about how to get the values of A, B, C, D, and E. And it looks like A is 1, B is negative 1, C is 0, D is negative 2, E is negative 1. So we have 1, negative 1, 0, negative 2, negative 1. And E is negative 1. Okay. So let's go back here and erase this. So now we have this A is 1, B is negative 1, C is 0, D is negative 2, and our E is negative 1. So let's bring everything down here, or at least copy it. So this fraction is written as 1 over x minus x over x squared plus 2. I'll put plus a 2x minus 1 over x squared plus 2 squared. Okay. Now, what we're going to do is factor out, looks like we want to try to factor out here the -2, or just a negative, I'm sorry. We'll have 2x plus 1 here. Okay. So what that does is we have 1 over x minus x over x squared plus 2 minus 2x plus 1 over x squared plus 2 squared. And we'll do a little bit more algebra here so that we can write this as 1 over x minus x over x squared plus 2. We're going to distribute here. This is a sum, by the way. You have a sum where both terms are divided by the x squared plus 2 squared. We're now going to distribute this negative sign. And you end up with 1 over x minus x over x squared plus 2 minus 2x over x squared plus 2 squared minus 1 over x squared plus 2 squared. All right. So remember, the whole idea is to integrate this. So what you end up getting is 1 over x dx minus x over x squared plus 2 dx minus 2x over x squared plus 2 squared dx minus the integral of 1 over x squared plus 2 squared dx. So this is going to be 4 integrals, but I'm going to bring out my constant 2 here. Oh no, we'll leave it. Okay, so by properties of integrals, we now get, looks like we got 4 integrals. The first one is the natural log absolute value of x. It's pretty simple. The second integral here, we're going to have to use u sub, where u is going to be x squared plus 2. And I will say here, maybe we'll change colors. We're going to use u sub in green here. U is x squared plus 2. And then in purple here, this is not going to be u sub. We're going to have to use trigonometric substitution. Okay. So the first integral here, we're going to do the work in red. X squared plus 2 dx. Well, u is x squared plus 2. Yeah. Du is 2x dx. Dx is du over 2x. So we have x over u du over 2x. 1/2 integral 1 over u du. 1/2 natural log absolute value of u. It'll be plus c. We'll add those constants at the end. U is x squared plus 2. So I moved from the absolute value sign to a parentheses because of the fact that u is always going to be positive. So just remind you guys that. U is always positive. This is the red integral. The green integral. (2x over x squared plus 2 squared dx), where u is x squared plus 2, du is 2x dx, and dx is du over 2x. So this integral becomes 2x over u squared du over 2x. 1 over u squared du, u to the minus 2 du, u to the minus 1 over negative 1 plus c, negative 1 over u plus c. Or negative 1 over u is x squared plus 2 plus c. So this is the green integral. Now, the purple integral, trig substitution, 1 over x squared plus 2 squared. Let's double check. Okay, now when I say we're going to have to use trigonometric substitution on this here, let's go back really quick. Trig sub. Look for this. Let's go back here. I'm gonna have to fix that, so let me work on that. Where am I looking for? Oh yeah. For canvas, I guess. Canvas, yeah, here we go. Sorry about that. Canvas. It's really case 2 here. Where x is a tangent theta, and then the radical is a secant theta, although we don't have a radical. So x is a tangent theta. X is the square root of 2 tangent theta, because the a value here, or I should say a squared, is the value 2, which means a will be plus or minus square root of 2. Remember, a is always positive. So here's my x. Now, dx, derivative of tangent, is secant squared. All right, and then if we say, what is x squared plus 2? Well, that will be square root of 2 tangent theta squared plus 2, which becomes 2 tangent squared theta plus 2. Factor your 2 out. Tangent squared theta plus 1, which is 2 secant squared theta. Now don't forget to raise this whole thing to the power 2. get 4 secant to the 4th power theta. Let's double check. Okay. All right. So the integral is really 1 over 4 secant to the 4th power, and then our dx is square root of 2 secant squared theta d theta. All right. So I get the square root of 2 times 4 integral of 1 over secant squared theta d theta, because the 2's cancel. Right? That's going to be power 2 now. And let's get the right color. This becomes the square root of 2 over 4 integral of cosine squared theta d theta. Square root of 2. Replace this with 1/2 1. Remember, for cosine squared, you're going to use the power reducing formula. So I think it's going to be plus cosine 2 theta d theta. Okay? Just going to double check something here. All right. So pulling out the constants now, you get the square root of 2 over 8, integral of 1 plus cosine 2 theta d theta. Square root of 2 over 8 theta plus 1/2 sine 2 theta plus c. Square root of 2 over 8 theta plus the square root of 2 over 16 sine double theta. So if you recall what you do with sine double theta, you replace that with 2 cosine theta sine theta. So we get square root of 2 over 8 theta plus the square root of 2 over 8 cosine of theta sine theta plus c. Okay, this is trig sub. So remember what we did with trig sub here. Let's recall that x is the square root of 2 tangent theta. And what that means is tangent theta will be x over the square root of 2. Let's move this all down. All right. So here's our theta. Opposite over adjacent, which means the hypotenuse is x squared plus 2 by the Pythagorean theorem. And I believe that's squared. because if this is A, B, C, A squared plus B squared is C squared. All right. We need, first of all, what this means now, since x is, I want to do that. Theta is inverse tangent x over the square root of 2. Sine theta is x over x squared plus 2 squared squared. Cosine theta, square root of 2 over x squared plus 2 squared squared. All right. So, square root of 2 over 8 inverse tangent x over square root of 2 plus square root of 2 over 8 cosine theta square root of 2 over x squared plus 2 squared. And I guess I'll put the sine theta x over x squared plus 2 squared plus c. Square root of 2 over 8 inverse tangent x over the square root of 2 plus, looks like that'll be 1/4 x over 4 x squared plus 2 squared to the 4th plus c. Now I'm going to double check something here. Yeah, something's bothering me. Pythagorean theorem. X squared plus b squared equals c squared. Yeah, this is all without the power 2. So apologize. C squared is a squared plus x squared. That's all. Good. So that makes some sense. So let's go back. Okay. This is your hypotenuse, which means this is the power of 2 instead. That's what I thought. All right. Good. Found the error. And this is what you have in purple. Now, just to put this all together, let's not forget, we had natural log absolute value of x. And I believe the next term is minus the red integral. So it's minus the 1/2 natural log x squared plus 2. And then we're going to subtract the green integral, but don't forget there's already a negative sign in front of that green integral, and there's a negative sign here as well, so minus the minus makes that a plus. So it's plus 1 over x squared plus 2. And then it's minus the purple integral. So it's minus everything you see here. Square root of 2 over 4 over 8, inverse tangent. Minus x over 4 x squared plus 2 squared plus c. Yeah. And, you know, just to, I've always put the conclusions in black, so I apologize. Let's see if we can write this nicer. This late. Anyway. There you go. So number 12 is a very similar question. It's very similar. You have a linear factor. You got to repeat quadratic. So 10 over x plus 1 times x squared plus 9 squared is a over x plus 1. Now let's deal with the repeat quadratic. X squared plus 9 to the first power plus x squared plus 9 to the second power. You get bx plus c plus dx plus c. Linear, first power, second power. Repeat linear. So what I'll say now again here is use partial fraction decomposition where we need the values of a, b, and c. A equals, b equals, c equals, d equals, e equals. We need those constants due to partial fraction decomposition, because we're coloring blue. And with this question, yet again, you can go back to, we did that one as well. I did that one already. Get the values of A, B, C, D, and E. So you can check that. Let's find out what these values are. There we go. A is 1/10, B is minus 1/10, C is 1/10. 1/10 minus 1/10. C is 1/10. D is -1 and E is +1. -1 and +1. So ladies and gentlemen, here you go. So we get 1/10 over x plus 1 plus negative 1/10 x plus 1/10 over x squared plus 9. And then you get plus that negative x plus 1 over x squared plus 9 squared. Okay. So we're going to do a little bit of the factoring over here again. Negative. Factor out the negative sign. So minus 1/10. Negative x minus 1. So we get 1/10 over x plus 1 minus 1/10 x minus 1/10 x squared plus 9 minus x minus 1 over x squared plus 9 squared. So simplifying a bit more, 1/10 x plus 1 minus 1 over 10 x squared plus 9 minus x minus 1 over x squared plus 9 squared. So what we can end up doing with this last portion is also a little bit of the algebra that we did. And that's going to be, we just focus on the fact that we have a difference over, we're really distributing the denominator, the x squared plus 9, it's dividing both terms. It's dividing that difference. And this is the portion in gray, by the way. So let's see, ladies and gentlemen, that's what we get. Minus x over x squared plus 9 squared, minus the minus makes this last one plus. Okay, and don't forget, again, all of this was about integrating. So we were integrating this, which means we were integrating this whole thing. Okay, so by properties of integrals now, you get 1/10 integral 1 over x plus 1 dx minus 1/10 integral 1 over x plus 9 dx minus x over x squared plus 9 squared dx plus the integral of 1 over x squared plus 9 squared dx. So again, just like the last example, we get a nice easy, let's just do this, let's just write out what it is. It's the natural log, absolute value of x plus 1. Again, over here, oh, this one's nice too. X squared plus 9. And this would be 3 squared, is that right? So, if you can recall, let me try to find some space for this. Let's make space. its inverse tangent? 1/3 inverse tangent x over 3. Over here, you have to use u sub. For u will be x squared plus 9. And then over here again, like before, it's a quadratic integral. Here we have to use trig sum. I believe x will be 3 tangent theta. Alright, let's do the red integral again first. X over x squared plus 9 squared dx. Let me just make sure everything is what it should be. Okay. Just going to go back over here. I'm kind of curious about something. It's just different values. All right. Okay. So what are we doing? The red integral. Okay. U x squared plus 9 du 2x dx dx d over 2x. So this becomes x over u squared du over 2x 1/2 the integral of u to the minus 2 du 1/2 u to the minus 1 over negative 1 plus c negative 1 over 2u plus c 1 over 2 x squared plus 9 plus c. And I do not like that automatic whatever that is. 2 x squared plus 9 plus c. Now, the trig sub question, purple. 1 over x squared plus 9 squared dx. Yeah. Okay. So x will be 3 tangent theta. Dx is 3 secant squared theta d theta. Now, x squared plus 9 is going to be 9 tangent squared theta plus 9, which is 9 tangent squared theta plus 1, 9 secant squared theta. But we're supposed to square this. So we end up with 81 secant to the 4th theta. So that integral is 1 over 81 secant to the 4th theta, because that's the x squared plus 9 squared, and then dx is 3 secant squared theta d theta. So we can see this is 27. This is now the power 2. So we get 1 over 27 secant squared theta d theta, which is 1 over 27 cosine squared theta d theta. Okay. Power reducing formula. 1 over 54, integral 1 plus cosine 2 theta d theta. So we can integrate 1 over 54 theta plus 1/2 sine 2 theta plus c 1 over 54 theta plus 1 over 108 sine 2 theta plus c. We replace sine 2 theta with 2 sine theta cosine theta. So now we get 1 over 54 theta plus 1 over 54 sine theta cosine theta plus c. But if we go back and remember that we have x is 3 tangent theta. Copy. So x is 3 tangent theta, that implies that tangent theta is x over 3, which means theta is inverse tangent of x over 3. So we have part of our answer. Let's create our right triangle. It's not a right triangle. Opposite over adjacent, which means this is x squared plus 9. Sine is x over x squared plus 9. Cosine will be 3 over x squared plus 9. So we have everything we need. 1 over 54 inverse tangent x over 3, because that's what theta is. We found that out right here. It's our theta. Plus 1 over 54. 1 over 54 sine theta, x over x squared plus 9, and cosine theta, 3 over x squared plus 9 plus c. So you get 1 over 54 inverse tangent x over 3 plus 54 divided by 3, ladies and gentlemen. It looks like it'll be, if you recall, 18. 1 over 18 x squared plus 9 squared plus 9. All right, I think we did everything okay. So, ladies and gentlemen, let's go back and let's try to remember everything that's here. It's kind of late, but okay. 1/10 natural log x plus 1. And then minus 1/10. Here's what you want to remember. You got minus 1/10 times this whole thing, so it's going to be minus 1 over 30 inverse tangent x over 3. All right. Then the minus the red integral, that's a minus the minus. So here's what I'm saying. It's already a negative. The red integral is negative, so that's plus 1 over 2 x squared plus 9. And I think that now means we're going to add the purple integral. Yeah, we're adding the purple. So plus 1 over 54 inverse tangent x over 3 plus, I guess that's what we have, x over 18 x squared plus 9 squared. And I guess we can combine, like terms here, but I'm not this late. And I'll share that with you guys here. So I'm going to send this out to you guys. It looks like we could combine the inverse tangents, but 1 over 54. Let me see, I might do that in the TI. And you guys can't see that, but maybe I might be able to get you guys to see that. Let's see what I can do. 1 over 54 minus 1 over 30. Of 54 minus 1 over 30. Okay, TI, let's wake up. Okay, and we're going to say math frac minus 2 over 135. All right. Minus 2 over 135. So I'm going to do this. And I guess we'll leave it that way. Okay, ladies and gentlemen, I'll send this out to you guys. I hope everything's okay. I hope it's correct. And have a great spring break.